All right, good evening. We're going to get going. Thanks for coming. Those that are not here, where are you? So we have a bunch of problems tonight and some multiple choice. We're going to get a little practice with that. So I picked a bunch of multiple choice. I've never done that at this point as well. Trying to continue to push that and see how we're doing on that. So again, calculators, orange sheets. We're going to get going, see how some of these work out. And I just skipped like 3 pages. Or all the pages. Okay, there we go. Okay, so Dan, you should have picked up a packet and a sheet. So first problem says a 1.22 gram sample of pure monoprotic acid, HA, was dissolved in distilled water. The HA solution was then titrated with NaOH. pH was measured throughout the titration, and the equivalence point was reached when 40 milliliters of NaOH had been added. The data from the titration are recorded in the table below. Okay, so A. Explain how the data in the table above provide evidence that HA is a weak acid rather than a strong acid. So why is HA a weak acid instead of a strong acid? There's one real specific thing that you could just say without having to do a lot of extra meaning. Anybody?
The pH is over,
Is
at equilibrium.
at the equivalence point. Yeah, so at the equivalence point, this is the equivalence point, careful, not equilibrium, it's above 7, so it's greater than 7. So then you could say, well, because NaOH is a strong base, so that you don't have to go into further details, though. You don't have to be like, well, it dissociates it further, and because of that, it has a conjugate base that's on the other side, and you don't have to say any of that. You just have to say the equivalence point is greater than 7. That's or pH of 7. And that's just going to be a point. They said pH of the equivalence point is above 7, which indicates HA is a weak acid. Okay, so look, usually they don't start off huge. It's not like they hit you all at once. So that they're trying to give you some information. I guess I'll say before moving on, never underestimate the information that's given to you in the beginning. Make sure that you are reading it. If you're not understanding it, read it again. And as you go through it, maybe the information will help you actually understand it better as well. Okay, so 1 point. Good start. Letter B. Write the balanced net ionic equation for the reaction that occurs when the solution of NaOH is added to the solution of HA. I'm going to let you try to do that on your own, and then if you like, match it with someone else, or just wait. So let's see what we can do on that one. Write the equation. Equations we should get, we should be able to do. To be technical, is this a double arrow or a single arrow? What's the weak acid? What's the HA reactant? Strong base. Technically, I don't know if you would actually get marked off or not, but technically, because it's with a strong, it should be a single arrow. So what do we always do if you're confused? And we always write these actually as net ionics right away. Is you take your acid and you react it with a base. Here's the net ionic. That's the whole point of that part. Whenever we have acids or bases, what if it was a strong acid? What is the only thing that we're going to be writing? Probably is H plus, right? And if it's a strong base, we're writing OH minus. So right there, that's where it kind of starts. And then this is one way to do it. Not sure if they did it another way. No, they did not. So 1 point is earned for writing the net ionic equation balanced for mass and charge. So that's how that should look. Pretty standard, pretty typical, but got to be able to still pull it off. All right. I'm assuming calculations coming up soon. Oh, wait. Calculate the number of moles of HA that were titrated. Okay, so what does that mean? You want to know the number of moles that were sitting in the bottom. Remember, you have to have an idea what's happening. You got this burette here, and then you got the Erlenmeyer here. You got your HA down here. You got your base going down. Okay? So, what are you working at? You want the moles of HA. How can I figure that out? What part of this graph or this table tells me that? Based on all the information that's given to me. Anybody know what spot matters? Only one spot that matters. I want moles at the, get from the equivalence point. Why? Because that's where the moles of my base equal the moles of my acid. And look at what they've told me. They've told me things about my base. Okay, they've told me 2 things about my base already. And do I know anything about the acid? I know a little bit. I know grams. Unfortunately, I don't know the molar mass. So I know moles, I want moles of acid, or HA, at equivalence point. Remember, here is where moles of A equals moles of B. So when moles of A equals moles of B, that's M1V1 equals M2V2. The problem is I wasn't given grams necessarily, but I can at least figure out the moles of B, which that's all that I need. Right? So how do I figure out moles of B? What am I going to use if you haven't already done it? Or if you have done it? What do I have? Hunter, what were we doing? Yeah, I know. So, sorry, what is it exactly? You have it? What's the volume of the base?
40.
Okay. And is it 0.25?
Yeah.
Oh wait, can I do millimoles? Unfortunately, the question is asking for actual moles, so you got to be a little careful. If I was being able to get in and out of millimoles, that's different. But I'm actually asking for moles, so I have to do that way. Technically, that's not good the way I wrote that. How should I write that technically? Just one? I could write it like that. I'm talking about sig figs, I guess. Technically, should have written it like that. Just saying. I want to be as consistent as possible. And if you're like, well, you didn't write it there, I probably didn't write it correctly because it said 40.0. I wasn't looking at it. 40.0 is 3 sig figs. So this would have been like that. That's a 0. Okay. Just 1 point still. So not a lot. They're setting you up. They're building us up. I actually like problems that are slowly making me give information, because that means that I don't have to do it all at once. I'm getting credit for each thing, which is kind of nice. Says D, calculate the molar mass of HA. What's molar mass? Molar mass is, remember, if you don't understand it completely, you always got to at least think units. Molar mass, grams per mole. So just execute the 2 things you have. You have grams, you have moles. No, I don't. Reread the problem in the beginning. You should have grams. And I'm trying to do a lot of problems 1s, 2s, and 3s. Those are worth the most. And so far, I would love this problem. And if you're like, I didn't understand this one thing, but in general, it's kind of feeding me the problem slowly, which is nice. They did it a little differently. Oops, I'm looking at the other problem. Nothing. So I had 1.22 grams, and we're at 0.0100 moles. So 122. 1 point again. Everything's 1 point right now. Okay, so it kind of set us up, gave us some points. It's probably going to get a little harder. It cannot stay that easy on a 1, 2, or 3. There's got to be something. It's got to be a little complicated issue that's going to occur. So the equation of the dissociation reaction of HA and pure water shown below. Okay, they give you a Ka. E. Assume that the initial concentration of HA solution before any NaOH was added is 0.2 molar. Determine the pH of the initial HA solution. What do you have to do? Ice box. Believe it or not, if you're like, ice boxes are easy, I don't even need to write them. That is considered really difficult. Most students in the nation will not get this problem right. What do? To save everything that you've worked on, write the equation out, please. Write it out, organize your information. Gosh, the minute they say pH or find Ka or how much of a concentration is present and they're giving you Kas or it sounds like an equilibrium, do yourself a favor and start writing out an icebox and see what you have. So what I'd like to take a step back and let you try to complete this, because you should be able to. This one right now so far. The next part's the real hard part. But there's points sitting here. Just give you idea. There's 3 points in this one. This is a 3-point question. If you are still working, don't look up. One thing I will say, if I was actually doing this on the test, because I think I've proven to you, or I hope I've proven to you, that time is not usually really the issue, I would probably show all the work in an ice box, because you're not going to have to do that many. Because what if that is part of a point? Like, show the stoichiometric relationship. Well, the stoichiometric relationship is using ratios and going from one side to the other and all that stuff. That's what it's all about. Good to see when it's a big problem where you get points. That is a question we have done so many times. You got to just recognize, okay, they gave me an initial, they want a pH, right? X squared over initial minus x. I'm going to find OH minus or H plus, right? One or the other. And then I move forward. What if they told me the pH was, I'll make this a 2.45 already. What does that ultimately give me? It gives me the concentration of H plus or OH minus where on my table?
Yeah.
On the bottom, right? Always on the bottom. And then you work backwards. So probably if they told you a pH, I'm just going to guess. There's 2 ways that they could have a question then. Either find another concentration, find an initial, or somehow find a K. Because if you have to do a K, that's nice. Oh, you'd have to know all of them. So again, the more you understand about how an icebox is set up, it's going to help you out that much more. So that was 3 points. Okay, now, my guess, I haven't even looked at it yet. My guess is now they're going to throw something extra in here or cause the icebox to fluctuate. So you're probably going to continue to work with this. Let's see what it says. Calculate the value of H plus concentration in the solution after 30 mils, there we go, of NaOH solution is added, and the total volume of the solution is 80 mils. Okay, so they're adding OH. When in doubt, write an arrow, and now think about it. I know I'm adding NaOH. So first, I'll give you 30 seconds. What equation am I dealing with? Think about what has to happen. Maybe, eventually, I'm talking literal, you're going faster than I am. What is the chemical reaction? Like, what's the actual equation? Let's get that down. So I'll tell you this. I need this. Like, well, how do you know that? Because it said I'm adding NaOH to the solution. So what does the base always have to react with? An acid. So my only acid I know is that, right? Wait a minute, didn't I just do this? Right. Oh my God, because it's from the same problem. Crazy. Okay, so what's going to happen? Acids and bases consume each other, called neutralization. So let me write down some information they gave us. I'm confused, I don't know what's happening. Okay, so they added 30 mils of this. Now it says the total volume. So that means 50 mils had to be of that initially. Okay, so where do I get the rest of the information? Probably from the beginning. It gave me some other information. Okay. Otherwise, maybe I'm getting too far ahead of myself. I think it's the 30. Yeah, it's the 30. What do I need? What am I working with here? Moles first. Eventually I will be working with milliliters, but moles consume each other, not molarity. Moles is the amount of actual stuff, so I need the amount of moles. So, can you figure out the amount of moles I have? Well, one of them I know. What's the acid already? I've already figured it out. That doesn't change. What did we start with? I think we had to figure it out. Is it 0.01? Now, if you can be like, oh, they're equal, that's at the equivalence point. Notice they're doing it 30 mils. This is 10 mils before the equivalence point. So, what do I need to do? This is how I would actually do it. I would literally put the 30 mils. Now, this is the hard part. This is in moles. You can't do millimoles in moles. That doesn't make any sense. So, as I'm writing it, I want to correct that quickly. What am I multiplying that by?
Isn't that moles from the NaOH? Never mind, it's the same thing.
No, it was, but that was at the equivalence point. So what we did, that's a good question. We figured out that we had 0.01 moles of my acid right here. So now it's saying if I just drop 30 down immediately of my base, what's the new pH? Okay? Which, that's, hence why this is the question. By the way, it's got to be between these two pHs. That's something good to know. Okay, help me out. What's the molarity? It's molarity. How quickly I forget. Old age for me. Alright. So what happens? One has to get consumed, correct? So it's always a smaller answer. If they're both equal, then the pH is 7 and I'm done. Except the fact that these aren't strong, so that's still not totally true. I misspoke. That's totally consumed, and then you'd have that many moles added to the conjugate partner. Well, why doesn't that work with strong? Because all it does is make water. It doesn't make anything else. It makes a salt that never dissolves. So, clearly, one is smaller than the other. So, by showing my work like this, understand it's happening here as well. We haven't done this for a little while, but you were very good at it when we did this. Very good. Okay, so I have that, right? So now what? Evelyn, now what? Almost. You are right though. Total volume, but you're right. We're going to do Henderson-Hasselbalch. There are other ways, guys. You can replug this in now. You can take this, just hold on 1 sec. I can take these two values after I get them into molarity and now replug them into the beginning of these two compounds and then do an entire distribution again, and there's a lot of extra work. Or I can just be done right here by just simply putting it as an 80. I just put the work right here, and I'm just going to solve to the left and to the right. To me, that's always been the easiest. That's how I kind of learned it. You feel like, oh my gosh, this is long. It's worth points. Believe me. It's going to be worth points. And to be honest, I just expected that you should know how to do this. I don't treat this as something that, like, good luck. I view this as awesome. This is difficult, but we've done this. We have done this, we've worked on it, and we haven't done it that long ago that we actually might have a chance at remembering how to do it. Try not to get rid of too many sig figs. I'd rather, if it's only 4, don't cut it down to 3 now. It's not your final answer. You can do that later. Now, here's the issue. They don't do it this way. I can't imagine they would, but it's legit. They just took it. They got rid of Henderson-Hasselbalch. They have. So, let's see, because you don't get it on your sheet on Monday. Can you do it? If not, what you have to do again is you'd have to put those two numbers in my red boxes back in here, and then this is 0, so this is plus x, minus x, and then you have to put it all in there, cross out the x's, and then make it equal to 6 point, which is possible. Oh. But I do want to do this. This is the problem. What the question isn't asking for pH, but we can get to H+. I mean, it's asking for H+ concentration. It's still, to me, this is still the faster way, personally. you're trying to do it, don't look up, please. Anybody else? What do I do? Because that's technically not the answer. 10 to the negative. Please, I saw a few of you on your test do e to the. Careful. That's not that. It's the opposite of log. So if I do this, maybe this is a roundabout way. I don't know. Maybe. That's 3 points again. And what they did is they took the two numbers in the red boxes initially, they replugged it into the distribution. This was on the top, plus x times x over this minus x. You cross out the two x's. You have to divide that and multiply it to the side, make x equal h plus, and then you get the answer. Just so you see, I'd be curious. 1 point is earned for this. Those two numbers. 1 point is earned. I'm just laughing because the other point, I don't know how they would grade it. Probably plugging it into this thing, because they don't grade it like you did Henderson Hasselbalch. They grade it like if you plug it into the Ka expression. But anyway, that's the end of that problem. Take it or leave it, but that's where we're at. Okay. So, yeah, Nancy, you can go wherever you want. You can even run in the hall. I wouldn't go. Okay. Next problem is it 2012 question 3, I believe. Okay. Awesome. And I did not own that. I added this. It's all good. Okay, here we go. A sample of CH3CH2NH2, here we go, is placed in an insulated container where it decomposes into ethane and ammonia according to the reaction represented above. So there it is. And then below, you get in a bunch of data, which we can talk about. A. Using the data in the table above, calculate the value in joules per mole Kelvin of the standard entropy change in S for the reaction at 298. So you're given all the data. We've done this a couple times. You have an equation there. What do? Products minus reactants. You do have to make sure that everything is balanced. Because it's not in normal form, I would just double check, does everything have the right number of H's, C's, and N's? It appears to be. I see 2 C's, 2 C's, 1 N, 1 N, 7 H's, 7 H's. So that's important, right? So now it's just products minus reactants. So the biggest key to this is making sure you understand which one's which. And that's just a point. Hopefully, before I said it, you recognize that that's probably what you should have done. Okay. Letter B, using the data in the table below, calculate the value in kilojoules per mole of the standard entropy change for the reaction at 298. All right, so this is a big one. This is where students make a lot of mistakes. Bond, average bond enthalpy. If you're given enthalpies or entropies, you're doing products minus reactants. But if you're given it in terms of bonds, what are we doing? We got to break them, and then we have to make them, right? Bonds broken minus bonds formed. Wait, why minus? Because the energy goes into breaking them, and then it comes out when you form them. So there has to be a difference. So you have to subtract them. So you take bonds broken. It ever starts to write. There we go. Minus bonds formed. I think this is one big, if I could make like 10 to 20 things that students kind of forget or mix up, that's one big one, is with bonds, you have to do bonds broken minus bonds formed. So this takes some time. What you need to do is, I would list them all out. Okay, so for example, I'm just going to talk a little bit about one of them here. I'm going to do it up here. I have 1, 2, 3, 4, 5. I have 5 CH bonds, for example, right? Plus, this is a smart way to do this. Hash marks. And you might want to do a different hash mark or angle for each one. So that's a CC bond. Keep going. So this will be one set eventually. That breaks off here, and then you're going to subtract and do the other ones. I'd like you to see if you can find them all. They all should be present. Don't make up something new. Oh, I found this bond, and they're not listing it. Maybe you interpreted that really incorrectly. They're helping you out by showing these, by the way. A lot of times they'll just do the formulas like in this table that you see. Well, now you really got to come up with them. So I would actually suggest drawing them out, even if it's just really quick and sloppy. You need to make sure you have all the bonds. Work on them. Do not look up until you're ready. So these are, as you finish up, those are my bonds that I found. Then right below it, I'm going to do it above. Well, I'll do it below. It's the best description if you can actually show what you're doing then. So it's 5 times, and then you find them. 413 plus, and it doesn't have to be in this order. My gosh, if you did not find it in this order, I'm doing this on my own. I'm not using the answer key and knowing that there's a right order or not. It is what it is. So the biggest deal to me then, after making sure you understand that you do bonds broken minus bond formed, it is amazing how many times you don't get this right answer. Personally, for me, I get an answer on each side and subtract. I don't know why, but there's user error in this every time. Computer's like failing there. and that's correct. If you did not get it right, these are the numbers I got. And if you wrote, this is how you can kind of check your answers. I got basically this minus this. So if you got one of those two numbers, at least you know where you made your mistakes. Like, oh shoot, I messed up on the first half. Messed up on the second. Okay? 2 points. Let's talk about where you get it. 1 point is earned for the correct bond count and use of values from the table. 1 point is earned for the correct setup in terms of bonds broken minus bonds formed and calculated change of age. So basically, did you do bonds broken minus bonds formed, and then did you actually count them all up with the right numbers? So 2 points. C, based on your answer to part B, predict whether the temperature of the contents of the insulated container will increase, decrease, or remain the same as the reaction proceeds. Justify your prediction. And I think that some of you are going to get this wrong. I didn't say I hope some people. There's a big difference. I'll let you use the restroom. Okay. Well, Mason, what is this? Exo or endo?
This is endo.
Good. So if that's endo, what does a content feel? What do things feel like when they're endo? Cold. Like the Maroon 5 song. So the temperature will decrease because it is endothermic. What?
What kind of song?
It's not a kind. It's the new Maroon 5
Can you
song. So
sing
cold.
it for me? I don't know.
Sorry, I know you're not up on the newest songs that the kids are listening to.
I honestly don't know this song.
Listen to it during break.
But how do you know? But it says like the contents of the insulated container. Does that change?
These are the contents of the insulated container. This is what's happening inside the insulated container.
Oh.
It's like a calorimeter.
Oh, okay. I got it.
Yep. 1 point. All right. An experiment is carried out to measure the rate of the reaction, which is first order. Okay, little kinetics. A 4.7 times 10 to the negative third mole sample of that is placed in a previously evacuated 2-liter container at 773. After 20 minutes, the concentration of that is found to be that. D, calculate the rate constant for the reaction at 2773 Kelvin. Easy for me to say. Include units. Okay. There's a lot given there. Wow. Woo! Does anybody know what you do? Like, what do you in general are going to do? There's a huge hint that it gives. That would be maybe a potential, but no.
Divide the rates.
Maybe.
Oh, it's first. It's so it's.
Let me say a couple of key things. It says first order. It tells me moles.
It's first order.
Tells me a concentration, and it says after 20 minutes. Not a half-life, because that would be how much is left after half its life, but you're getting closer. We're using an integrated rate law. Now, I'm going to write it the exact way they have it on your equation sheet. I think this is how they have it written. So let's use it like that. How we learned it, like this. Oh my gosh, I forgot it. There we go. And then you just subtract it. But this, I mean, you're given this. Okay? So this is the at time. This is at 0 or at initial. Okay? Now, there's one little trick you have to do. So let's fill in what we can. Hang with me here. I'm solving for K. Stay focused on that. That means everything else has to be given to me. So at time, it says after 20 minutes, the concentration is found to be this. Well, that's this concentration. Now, they're doing a big hint or a service to you. They actually wrote moles per liter. They could have written M. The reason why that's a service to you is how do I know the concentration of the other one? At time 0, take a look. Yeah, isn't it? It's the amount of moles over 2 liters. Moles over liters is concentration. That's why they did it. So, because though actually I totally see why you were given a temperature, you're given a volume, you're given moles, it feels like you're getting pushed towards PV equals RT as well, but because it's at first order, it's kinetics, and they give you a time, that's why. That's actually how I would write it. Never shows up.
Whoa, whoa.
Okay, now you just gotta solve, see if you can pull it off. 3-pointer. 1 point is earned for the initial concentration. Guys, this is a point. Right there. 1 point is earned for the correct setup by just putting it in here in general. That's a point. So even if you miscalculate this, you're already sitting 2 out of 3. That's good. I want all 3, I'm greedy. But the only thing I'm ever greedy about in my life is wanting you guys to get good scores. Is that greedy? Is that like saint? Then, can you get the right unit? Because it's the right answer with unit. Dum, dum, dum. Oh, and by the way, I would have written this. And everything else. So if you can remember the trick, which is hard to do now, about how you get units for your K, it's a lot easier. It's flipped molarity over time, and the flipped molarity is 1 less than the overall order. So if it's one less than the overall order, I was told it was first order, so I rip it away. It's just inverse time. It's just inverse time. All first orders. Maybe memorize this. All first orders are inverse. Most things are first order. So my unit. This is gonna be fun. This is really exciting. I was doing that. Yes, it is. Mr. Lenz. So that's the last one. All right, finishing up. Calculate the initial rate in molarity over minutes of the reaction. Okay, anybody want to tell me what the heck or how the heck I do that? I plug it into the rate law. Notice I didn't say the word rate. And this I think would be hard to pull out after you did this sometimes. Oh my gosh, this is not cool. So we have rate equals K times the initial. The initial. What 2 things do I know now? I know my K. So even if you got the wrong K, you're going to plug that in. And then which one is this one? The one that's sitting right there, right? It's the initial. All rate laws start from the beginning, the initial rate. So all you got to do is plug that in and you get a new rate. Oops. So just plug that in. My computer cannot handle the information that's given there. I just say here, neither can we.
Neither can my brain.
I'll give this up a break. Like the Maroon 5 song says. This is only a point. I would have given this only a point because I could see if a student can't pull the trigger on this one, that's an issue. So, but I hope that makes sense. Let's finish this one up. take a real quick little break. I'll fight Hunter off from him taking my barbecue chips. If the 1 over that concentration is plotted versus time for this reaction, would the plot result in a straight line or would it result in a curve? Explain your reasoning. I am so confident as a group that you are going to get this right. So what is that saying? That is saying that is second order. It is a, now, it's not even asking if it has to be a positive or a negative slope, but I expected we'd even be able to draw it. Is it this way? Or is it this first or second? First or second option? If it's plotted on here no matter what, it always has a negative slope, right? Or am I wrong?
Wrong.
What is all the negative slopes?
Not.
These are all, in this case, I want to make sure you're confident in this.
Yes.
Why do I know those are the negative ones? Where are all the hints? Where can I get that hint from? We just actually okay. If you have your orange sheet, I want to make sure that we purposely wanting to get to this. Look at the second one. You see how it's not a negative K? Okay. Okay. So, I just want to make sure that we're feeling good about this. So, you don't have to say that though. You do not have to say that. All you'd say is it would be curved because that would be second order, and this is a first order reaction. Done, right? That's all you have to say, but you have to make sure you're saying that that's second order. You can't say, well, it's that's not, it's a first order, so that would do a curve. You have to say what 1 over concentration is. It's a second order. So the plot would produce a curve. Had the reaction been second order, the plot would have been a straight line. A plot of natural log of concentration this time would yield a straight line. That's 1 point. But the way we said it works just as well. Okay? All right, we're going to pause this for a sec. If I can ever get this up. Okay. So, hydrazine is an inorganic compound with formula N2H4. In the box below, complete the Lewis electron dot diagram. God, these are gifts. By drawing in all the electron pairs. Now, I've learned from the homeroom session that we had that you could do lines in between, but finish it off quickly. That's just probably the beginning of everything, but you don't want to make mistakes on this. Electron dot diagram.
What?
Dot. Yes, I know. Hopefully it looks like that. Gosh, I hope it looks like that. 1 point. The correct Lewis diagram has single bonds between, okay, I was just seeing if they had said anything specific that you needed to look out for. So that's just a point. B, on the basis of the diagram you completed in part A, do all 6 atoms in the N2O4 molecule lie in the same plane? Explain. So all in the same plane. So if I put it on the desk or I put it in my hand, all the atoms touch.
No.
So you might need to say a specific shape. What shape is this? So we take one of the center atoms, right? How many clouds? 4. Okay. So that's a tetrahedral. One's a lone pair, so that becomes trigonal, because 3 is always trigonal. Trigonal, so planar would all be in one plane. So things get pushed down, they make pyramids. Yeah, trigonal pyramidal. So this thing's a trigonal pyramidal. So what I would just say is, no, they will not all be in the same plane because the lone pair pushes down the H's below the N, making a trigonal pyramidal shape. Done. Just as an example. But it's definitely no. Let me read what they say. It says, no, they do not. The molecular geometry surrounding both nitrogen atoms is trigonal pyramidal. Therefore, the molecule as a whole cannot have all the atoms in the same plane. So, only linear, bent, and trigonal planar can all lie flat. Anything else will not. Okay, I lied. Square planar can as well. Hence the word planar. C, the normal boiling point of N2H4 is 114, whereas the normal boiling point of C2H6 is negative 89. Explain in terms of intermolecular forces present in each liquid why the boiling point of N2O4 is so much higher than C2H6. Okay, so it helps sometimes to draw it. So, help me out. Which one has a stronger IMF then? One with a higher or lower boiling point? Higher. So, this has a higher, stronger IMF, correct? Right? These are the little steps you got to get in your brains. Now, how do we do this? You name what both of them have, right? And then you say which one is the stronger or the weaker. So in this case, I just want to reread and make sure I'm answering the question correctly. Because if someone takes a final and doesn't answer greater than or less than, and they just say yes or no, then you can't get the right point. So it says explain in terms. So explain, actually, why is the boiling point of N2H4 higher? What does N2H4 have? Those have hydrogen bonds. Yeah. And it's not in between these, it's from one to the next, actually. So just so you understand that, FYI, it's actually this connection here of, whoops, I'll do it, of this H to that end. Like that, I didn't do that correctly. It's not actually here, it's going to be the attraction from one to the other, because that's what you're severing off. Boiling is a phase change, you're not breaking it apart. Here there's nothing to attract, because these have LDs, because it's nonpolar, right? So you have H bonding versus nonpolar. So the difference is that N2H4 has H bonding while C2H6 has LDs. H bonds require a lot more energy to overcome, to break, however you want to say, to break the forces to set, which causes it to become a gas. Let me read what they have. N2H4 is polar with dipole and basically hydrogen bonding between molecules, whereas C2H6 is nonpolar and only has London between the molecules. It takes more energy to overcome, this is probably the sentence you're needing to hear, it takes more energy to overcome the stronger IMFs in hydrazine, resulting in a higher boiling point. That's all I have to say. It takes more energy to overcome the stronger IMFs. So if you say which ones they have, and if you can say that H bonding is stronger than LDs, it takes more energy to overcome the stronger bonds or overcome the H bonds. 2 points. 1 point for identifying both IMFs. The other point for an explanation. Not a bad problem. D. I want you to do this all on your own. Write a balanced chemical equation for the reaction between N2H4 and water that explains why a solution of hydrazine in water has a pH greater than 7. I don't know how to do this equation. Think about what is present and then kind of fill in the blanks. So I'm going to completely step aside. Can you come up with that equation? They give you everything you need and something you don't know, but you can figure it out. What do I know is present on the right side? OH minus? Because it's greater than 7. That's the key. Otherwise, I don't know this equation. I've never seen this equation. Great, that's fine. So what has happened to my water? Lost an H. So the H has to go on the other one, right? So you got to get this part right. And this is where some of you are going to have the struggle. And what does that look like? N2H5 plus. Can you quickly do me a favor? This isn't part of the problem. Just below it, can you put A's and B's and CA's and CB's? Can you just do that? Good little exercise. Above or below, wherever you have room. You write A's, B's, CA's, and CB's. Let's make sure we understand them. I think that just helps. should look like that. Why? Acids lose H's. It's always good to just review that. Bases always gain H's. It's really easy for a chemist or a student to look at it, go this way, and then come back to the left and go, wait a minute, this gained an H, so this is a base. You're like, nah, that gained the H. That's why that's a base. Yeah, but it's right there. Now you're getting confused on where you are. This thing gained an H. That's why it's a base, because they gain H's. Okay, finishing up, a couple extra problems here. N2H4 reacts in air according to the equation below. By the way, the last one was 1 point. E is a reaction in oxidation reduction, an acid-base, or decomposition reaction. Justify your answer. Okay, so let's talk about a couple of these. A decomposition truly is one thing breaking up into many. I see more than one thing on the left. So for me, decomp is not the thought. So, what does a acid base have to do? We just talked about it. Has to gain or lose an H, right? Now there are these Lewis acid bases that gain and lose electrons, and it's really not an issue anymore. So we don't talk about it. So it probably is oxidation reduction. The problem is it says justify your answer. So what you need to do is you need to find something that gains charge and something that loses charge. If you can do that, then it's an oxidation reduction reaction. So little reminders. Help me out. What is oxidation number of something by itself? Those are zeros. Otherwise, we follow certain rules, right? We follow rules of H's always being positive ones, right? And O's being negative twos. That's a zero. So if this is 1 times 4 is plus 4, this is this overcomes me. Thank you. That'd be negative 4, so that would be negative 2. So right now I already see it. If nitrogen is negative 2, it went up to 0, right? So it gained charge. It went up. And oxygen went from 2 down to negative 2. So 3 dots. Because nitrogen and oxygen, you could even just say this. If you want to come up with the actual charge, I don't know if you need to, you could just say the oxygen and nitrogen are gaining and losing the electrons. Let me read what it exactly has. They do state the exact charges. They say the reaction is an oxidation reduction. The oxidation state of N changes from negative 2 to 0, while that of oxygen changes from 0 to negative 2. So you can just say what they do. And you don't have to say a lot more than that. So it's definitely, frankly, I don't think the hard part was to get to that part. I think just making sure that you say the right answer of the justification. Okay? 2 left. And I like these last 2. F, predict the sign of the entropy change in S for the reaction. Justify your prediction. And then indicate whether the statement written in the box below is true or false. I'd like you to do both those without me. Give it a shot. If you're not sure, skip one or skip to the other. I'm going to pause it for a minute. And as you're finishing up, let's see how we did. First off, predict the sign of the change in S. So all it's asking for is positive or negative, and then you just say why. So change of S is what, positive or negative? Positive. It's the simplest way I can say this. So I have to look at this equation. Wait. Yeah. No. Yes, this equation. What is it doing? What's 1 mole of gas to 3 moles of gas? Yeah. Now, I put in words, the reaction's gaining disorder from 1 mole of gas producing, from reacting only 1 mole of gas to producing 3 moles of gas. And that's all you have to say. I think the hardest part is for some of you is like, when do I stop explaining? I feel like I need to say more. You hit it. They like, yep, they remember that. Entropy change for the reaction is expected to be positive. There are 3 moles of gas produced from 1 mole of liquid and 1 mole of gas. The net increase of 2 moles of gas results in a greater entropy of products compared to the entropy of reactants. We're increasing disorder. We're gaining disorder. Letter G. I love / hate true-false questions. The state. Oops. Oh, I almost said the answer first. The large negative change in H for the combustion of hydrazine results from the large release of energy that occurs when the strong bonds of reactants are broken. I guess to me, whenever they sound like they're just proving something, it's almost always the opposite. I'm not saying that, but at least get your guard up. So, it says the large negative, so it's right here, change of H for the combustion results from the large release that occurs when the strong bonds of the reactants are broken. True or false? So you got to really analyze it. What I underline is key. It's not if it's a negative H. False, it's a positive one. Oh, you missed the mark. It is negative. Like, that's not the issue. They're trying to give an explanation. The true or falses are the explanation. Is the explanation correct to what they're saying? Release of energy, that's still true. Release of energy. So nothing's actually new yet. That occurs when strong bonds of the reactants are broken. So here's the key. Does energy, if energy, when you break a bond, you release energy, then it's true. When you break a bond, you don't release energy, then it's false. And when we release energy, what happened? When we break a bond, what do we do? You have to absorb energy to break a bond. You release energies when you make a bond. Wait, I don't understand. When you break a stick, when you play Red Rover, you have to put energy in. Believe me, I never broke through, ever. I would spring back. Literally, they'd throw me back. Like, we don't want them. So this is false. When you break bonds, you absorb energy. You put energy into the system. So you're like, well, wait, then it can't be negative. No, that's not the case. What's the issue then? Is it whatever when I break the bonds versus when I release the bonds, I must be releasing a lot more energy than it took to break the bonds. That's what it's saying. It took more energy releasing-wise to create those new bonds than the energy went going in to breaking the bonds. So this is false. Okay, that's always 1 point. Never more. Pointers are incorrectly identifying the statement as false along with the valid justification. All right. Another one down. Okay, let's take a look at another one. Eventually we'll change pace a little bit and we'll do some multiple choice and kind of do some different fields. Got an hour left. If you ever need to go, just go. All right. In an experiment, all the air in a rigid 2-liter container is pumped out. Then some liquid ethanol is injected into the sealed flask, which is held at 35 degrees. The amount of liquid ethanol initially decreases, but after 5 minutes, the amount of liquid ethanol in the flask remains constant. Ethanol has a boiling point of that, and an equilibrium vapor pressure of 100 torr. So you have no idea yet what you're doing. Just gives you some information. A, when the amount of liquid ethanol in the flask is constant, is the pressure in the flask greater than, less than, or equal to 100 degrees? 100 torr. Woo! Justify your answer. So when the amount of liquid ethanol in the flask is constant, and we want to say greater than, less than, or equal to.
Wait, when it means like constant, like means like not changing? Or like
Correct. So it has created. So okay, let me go back to the beginning because that was a little confusing. You have a totally empty flask, and you injected some ethanol, and the amount initially decreased. So something else happens to it, like it might have decomposed. I don't know. But then after 5 minutes, the amount leveled off. It has that boiling point and an equilibrium vapor pressure of 100 torr. So then it's asking, will it be greater than, less than, or equal to 100 torr when the flask is constant? Yeah, so it's equal. Guy, I don't know about you, but letter A is literally just putting the last sentence in reverse. It's just rewording the last sentence. Like it's basically saying it's constant and it has this pressure of 100 torr. And now all of a sudden saying, hey, will it be greater than, less than 100 torr when it's constant? It's just adding extra words to confuse you. So it'll be equal it's at equilibrium. Hope that makes sense. Like, sometimes I feel like they're trying to confuse you. Other times they're trying not to. They're going out of their way not to. And then sometimes because of that, it almost is more confusing. B, the flask is then heated at 45. And the pressure in the flask increases. So, okay, pressure increases. You can just slow down with these. Word problems sometimes are just, unfortunately, just a little more frustrating because we like to kind of put numbers to work. In terms of kinetic molecular theory, which just means, don't let that bother you, atoms colliding and moving. Provide two reasons that the pressure in the flask is greater at 45 than at 35. Two reasons. I don't know what they were all giving, but I know I see 3 bullet points. I don't want to read them. Anybody have any ideas? Any first name?
So when the temperature increases, the molecules move around more and they take up more space.
So they're moving more. What do you mean moving more? Moving faster.
Higher average
So they're moving faster. What?
So that means like since they're moving faster, they'd be colliding with the walls.
More collisions? That's actually what pressure is, right? If you pump a bicycle tire up, it's because you put more particles in, more collisions. Well, they're at the same speed, yep, more collisions. You heat it up, you go faster, more collisions. You got a leak, it decreases because there's less molecules, less collisions. All right, those are the two I would go with. Let me read a couple. There are 3 possible reasons based on kinetic molecular theory. 1, at a higher temperature, there are more ethanol molecules in the gas phase. Okay, we don't have the equation though, unfortunately. So there'll be more collisions, so you'll have more collisions. At the higher temperature, the molecules will be moving faster on average, thus colliding with the flask. So we might have to edit this a little bit. Because the molecules are moving faster, okay, so 2 of them they're both moving faster. Their collisions with the flask will exert a greater force. So, I want to be right, I probably would fall short, and I'm also like kind of only writing big bullet terms. So, if you're moving faster, greater force, okay? And what you could say, at a higher temp, more collisions, because more gas particles, or because I have a feeling this is one of those that a lot of people only had 1 out of 2, because it's like you got to be kind of specific. So I probably would have fallen short only because I probably would have short-armed this just a little bit. Let me just say one last time. Higher temperature, the gas molecules in the gas phase, there'll be more in the gas phase, so there'll be more collisions on the flask walls. At a higher temperature, the molecules will be moving faster on average, thus colliding with the flask more. So that one I think more we would get. And then the last one, because they're moving faster, they also have a greater force on impact on their collision. Okay? 1 point for each correct reason up to a maximum of 2. So if you could get up to 2 points. All right, then this changes a little bit. This is actually why I picked this problem. Concentrate, in a second experiment, which is performed at a much higher temperature, a sample of ethanol gas and a copper catalyst are placed in a rigid, empty 1-liter flask. The temperature of the flask is held constant, and the initial concentration of the ethanol gas is 0.01 molar. The ethanol begins to decompose according to the chemical equation. The concentration of ethanol gas over time is used to create these 3 graphs. Oh, hey. C. Given that the reaction order is 0, 1, or 2, hey, good. Glad we established that. Use the information in the graphs to respond to the following. I. Determine the order of the reaction with respect to ethanol. Justify your answer. By the way, to justify the answer, literally all you have to say is the unit and then saying the slope is a straight, or the resulting line is a straight line, or the slope has created a straight line. I'm not saying that correctly.
The slope is
Oh,
linear.
they tried to prank.
Yes,
us.
thank you.
They tried to prank
Yes.
us.
What order is it?
Zero.
It is 0, right? I mean, it's obviously the straight one.
Well, we weren't talking like order of the reaction, we were talking about the order of the graph.
No, I was talking about the reaction.
I was talking
They,
about
they
the
have them in
graph.
order. We
Wait, do you call it 0? Do you count
This is, like,
0,
they
1,
have
2?
it 0, then, like, this is the 0 order graph, this is the second order graph, and then that's the first order graph. Which is
Totally.
kind of
Yeah.
I
weird.
agree.
That's what I was commenting.
I didn't realize that until I looked
Sure.
closer. I was like, oh no, I know. How dare they?
But they never said it was in order.
I know, but I was
It's so
like-
cold. Zero order, right? Because this is how I would do it. Concentration versus time. Literally, I'm not dumbing this down. You get the points. You get the points for saying that. There's nothing wrong with saying that. Guys, 0 order. I didn't read this yet. The plot on the left is a straight line, indicating that the rate of decrease in ethanol is constant as ethanol changes. Therefore, the rate of reaction depends on check concentration. So 0 because it's a straight line. Double I. Write the rate law for the reaction. Ooh. Ooh. So what do? Rate laws only have reactants, correct? Okay. This is the shortest rate law you should ever write. Rate law, not integrated. Rate law. So what is rate law? Rate equals K times the concentrations. Upper right is order, right? Times the next reactant. Upper right is the order times the next reactant. If you add one, upper right is the order. So in this case, it's rate equals K. Oh, 0. Done. Gone.
Wait, is it negative K?
That's integrated rate laws. Hot dog. You see it now. This would be technically right. If you did that, that's okay. But you don't need to put that there because that negates it. It makes it a 1. Okay. So. Triple I, determine the rate constant for the reaction, including units. So I'm looking for the rate constant. Whoa. Whoa. So, first off, rate equals K, correct? Isn't that it? So what did we learn? The slope is the rate. Okay? So, a little rise over run action. Sound like Mr. Blackford? That's how he would say that right there. A little pluggage and chuggage. Actually, I thought it was pretty good. You pick any numbers you like. But by doing that, you should get the right units. Doesn't really matter as long as it's positive at the end. Get something like that. I just made it. Yeah, whoa, it's a negative. I know. Yep, you could go the other direction. It'd be fine. It's established that it's not a negative value. Can't have a negative rate constant. That's why we put the negatives in there. We put the negatives in there to offset it. Okay? Like within the equation. So they just want the constant. Okay? 1 point. 2 points. 1 point for actually understanding that you're doing rise over run. 1 point for the answer. D, and then we move on. You're doing well. The pressure in the flask. I mean, how else would you want to spend a Saturday night? pressure in the flask at the beginning of the experiment is 0.4 atm. If the ethanol completely decomposes, what is the final pressure in the flask? This is not as hard as it sounds. Correct me if I'm wrong, because I'm not looking at it. I'm looking at that equation. It's saying that it starts initially at 0.4 atm. If it completely decomposes, what is the final pressure? Why 0.8, Hunter? You're right.
Partial pressures, because 1 mole, there's 2 moles of gas, and they're both at 0.4 atm.
Yeah, pressures are like moles. If you start with 1 mole here, and you create it the other way, you'd have 1 mole of each of these gases, right? You'd have double the amount of moles. You went from 1 mole of gas to 2 moles of gas. If that 1 mole of gas is carrying 0.4 atm, both of those other moles of gas would be carrying 0.4 atms, because that's where it came from. That's how that results. So basically, you're doubling the amount of gas that you're creating. It says completely decomposes. That's a whole different problem if it doesn't completely. Now you got a lot of math that you got to have to figure out. They're just trying to see if you understand that. So if you start with 0.4 and it completely goes over to the other side, you have 0.4 and 0.4. So, and if it says, does it say justify? I'm sure it does. No, it does not. Wow. If you did though, all you have to do is say you went from 1 mole of gas to 2 moles of gas, you double the amount of gas, you double the pressure. Okay? So, 1 point. Right. I'll give you guys the call on this. You want to change pace a little bit, or you want to finish one more story problem, take a break, and then change gears?
Yeah.
What's our last?
Let's do one more story problem. Let's finish this and then take a break, okay? So we'll do this last one. So flip the big page. Hunter, not even wanting to know your answer apparently. I'm just moving forward.
This one knows about this, right?
We're past that. Okay. I picked this one because it has a little bit of math, but it's more like Stoic stuff. And I feel like we struggle with that constantly, wanting to know some things. So does this correlate? Is this the big page?
Yes.
Okay. All right, last one, we'll take a little break, and then we'll end in a kind of a more fun, different, maybe group kind of setting here. Answer the following questions regarding the decomposition of ASF5. A 55.8 gram sample of ASF5 is introduced into an evacuated 10.5 liter container at 105 degrees Celsius. I don't think I have to say this, but please never get confused by the word rigid or evacuated. That just means nothing else was in there, right? So it's only that gas. Okay? I, what is the initial molar concentration of ASF5? Okay, molar concentration is moles over liters. Okay? So, you need moles over liters. Please, figure out what you think you need to do. It's worth 2 points. These are ones where, these are grinder problems to me. This is where you got to take a breath and just suck it up and be like, okay, I know how to do this. It's just a little tedious. I'm going to have to probably do some T-charts. I'm probably going to have to show some units. I'm probably going to have a couple calculations. These are grinder problems. These are the difference, though, between maybe one grade and the other. Points. 1 point is earned for Oh my gosh. 1 point is earned for the correct molar mass. I'm not. Holy cow. AS plus 5 times F. Now you feel like, oh my god, I didn't get that part right. I don't remember ever seeing that in another problem. 1 point is earned for the correct calculation. That's funny. I'm not going to say I'm.
Maybe they're looking at it as like if you're solving for the molar mass, you're gonna get like if you get the molar mass right, you're gonna get.
Well, you do. I just think it's funny that I would have worded then the correct moles. I mean, literally, you could have botched all this and literally just somehow came up with a molar mass somewhere, and you would have gotten the point. Although then the next one you're not going to get. All right, double I. I'm not complaining. I like it for us. What is the initial pressure in atmospheres of ASF5? Okay. Any thoughts? Ashley's been waiting. She's like, tonight, I'm going to contribute, and I'm going to say PV equals nRT. Gosh darn it, I'm going to get it. No, you're right. I'm just kidding. I don't want you to feel like I'm lowballing you on this. How many points do you always get for PV equals nRT? 2. 1 for the correct substitutions or setups, and then 1 point for the actual answer. So in this one, we did have to convert. A lot of times they give it to you in Kelvin. They really do. It's kind of funny. They do as much as they can to help you out, because you got a lot to know. But when you're all said and done, that's your ATM.
Whenever it says R, do we always use that number normally?
Well, it's with, yeah, it says in atmosphere, so then yes, because that's the one with ATM in it. I don't think I've ever seen an AP, good question though, I've never seen an AP problem that ever uses a different R value. And I know in first year chem we made you know a lot of the other ones. And that's truly what you do more. This is, I hate to say dumb it down, but they try to keep you real focused, I guess.
Okay.
That's a better way to say it. 2 points. Okay. Resetting. It doesn't mean that the other stuff isn't potentially open for fair, in a problem. Could be fair game. At 105, so same conditions. ASF5, that's why you don't get the right molar mass. You don't see it. Decomposes into ASF3 and F2 according to the following chemical equation. B, in terms of molar concentrations, write the equilibrium constant expression for the decomposition of ASF5. Wow, that is really a complicated way, a real complicated way of basically asking you to write an expression solving for. Well, I don't know. It's just, it's not KP. What just happened? What am I solving for? Oh, yeah. Oh, is that? You were saying like it's me. I just thought you were like making sure no was represented or something. No, but Mason brings it up a good point. He's like, whoa, why isn't it KP? Because they actually said that. Okay? It's funny because I'm like, I think that's why she did that. Was she doing a violent act that day? If you call me again, I'm going to chop you. Fight. After Monday, okay? Thursday, large group. We'll get the PLL2 room. We'll move all the tables. We'll throw money down in the middle. All right. right. Wow. This is turned. When equilibrium is established, 27.7% of the original number of moles of ASF5 has decomposed. I'm going to write it down here. Calculate the molar concentration of ASF5 at equilibrium. Okay. So, I just want to have that out there. Anybody? Thoughts? Anybody have a thought of how they're wanting to start this problem? And maybe it's not the way that I would do it, and that's okay.
Isn't it just number of moles times
Is it?
yes?
Okay. So calculate the molar concentration of ASF5 at equilibrium. It says when at equilibrium established, 27.7% of the original number of moles of ASF5 has decomposed. So 27.7% of it. I was getting excited. I'm thinking about what double I is by asking. So what's the initial? Hold on. No, you can go. Calculate the molar concentration. Is it 0.0313?
Yes.
Is this the original? Okay. Is that right? Or is that wrong? Why? By the way, I'm just writing this down because I just heard everybody say multiply by 27.7. Why is that? So 27.7 of the original moles have decomposed. That means 27% of it is gone over there, correct? Aha. So, I mean, you could get this answer and then subtract it as well, couldn't you? Or, what is it going to be? 72.3% still present. I guess to me, if you write it down like, oh, I just take this and this and I'm done, take a breath, just go, wait, is that what it's saying? Because usually there's always one even little micro step that you might have to do, like, oh, I need to subtract that, or oh, it's the other half of that, or whatever. Okay? So just be careful. So that's how much is left. Now, this is where I'm curious what people think. Double I, using molar concentrations, calculate the value of the equilibrium constant. I have to calculate K. Any thoughts? I would do an icebox as much as I need to do an icebox. That's how I would do it. So if I have this, okay, I'm going to assume I'm writing ice. I'm in. I'm all in. I know. I'm going big. Okay, so what do I all know? What's this? Are these zeros? In the beginning, nothing happens, right? What's the other thing I know? Wait, so if I'm solving for K, what do I need to know by the time I'm done with this icebox? I need to know all that, correct? I need to know all that. By knowing the idea that you need to know all that, that means the icebox has to provide all that for me. So where does the 0.0226 go? Bottom of? Right here. Well, what's the point of that? Oh, that's a pretty big point. That's my algebraic equation, if you want to call it that. It's the weakest algebra testable. Technically, it's all in fractions. But I can see some people doing plus 0.0226 on the other side. That's not x. Okay? Slow down. Let the icebox answer that for you. Okay? So, what I'd like you to do is plug this in and solve for your K. Oops. It didn't work. Let's not get hurt. I have a breakfast to make. Oh no, not. What's going to happen with our Sunday review? No, who's going to make us breakfast? Holy cow. 3 points. Oh. 1 point is earned for having these two values. See, they don't do it with ice boxes. They make these hard mole ratio relationships, and it makes it more difficult. No, the 1 point is not earned if the student indicates just that these all equal each other, which because they can't. 1 point is earned for the correct calculation. Oh my gosh. So by writing this down, you're saying that they're equal, and by getting the calculation, you get a point. By saying they're equal, you get a point. So by saying that they have the same number, you get 2 points. And 1 point is earned for that. Final one. And then we'll take a little break. We can smell more of the biohazard waste. Calculate the mole fraction of F2 in the container. Mole fraction means moles of that thing over total moles. Okay? So, you got to be careful. I want mole fraction, so I need moles of this over moles of all three of these. So, what are all those? Those are all molarities, right? What's the volume? Is it 10.5 liter?
Yes.
It's tedious. But you have to get this all into, you got to get into moles. But luckily there's not too many numbers. So, see if you can get the answer. Or do you have to do that? Actually, I'll just ask that. Why don't you have to do that? I would have probably done that because I'm like, oh my god, it's in molarity. And I'd be going too fast. Why don't you actually have to take it out of molarity?
Because they all have the same volumes.
They all have the same volume. Yeah, so I wouldn't have done that. I would have changed them all. That's where my mind first went, which it would have been fine. So I would have taken each of these, multiplied by 10.5. I would have gotten all my moles. Then I'd have to add each of them up, divide it all. That's a lot of work because it's only 1 point. I know you don't know that, but I do. So, because I just look. So this is how it should look. Let's just cut to the chase. And this is how I would show it. Doesn't matter the order here as long as I'm showing it all. Am I doing this wrong? Well, that's fine. Oh. His calculator. Wait.
I got 5,000%. I was like, no, it's not.
Yeah, that would be no. Yeah, this always has to be less than 1. Like, no, it could be more. No, it's a mole fraction. It's a literal fraction of a whole. So it can never be greater than the whole, ever. So if you get it right, do calculate it. I'd like you to get the answer. There's never a unit for mole fraction because it all cancels out. Okay? All right. Let's take like a 5-minute break. So, we are going to give a little over a minute per question. My suggestion, stop starting early. You can approach it the way you like, just go straight forward, or how you would maybe on the test where you're like, you know what, I know how to do that, but I know it takes calculations and it's going to be a little more difficult. Oh, I don't know that one at all, I'll save that until the end. Personally for me, I'd go through all the ones that I can do that I just can get without doing any calculations and I know it. I'm going to put a plus sign next to ones that I think I know how to do, but it's going to take a while. I'm going to put a negative sign next to ones that I have no idea how to do. Go through it all first, come back, do the ones that have the pluses, then when you finish the pluses, go to the negatives. I'm going to put the timer up so we can kind of physically see it. I'm going to leave it up even if you're at home, which you should be here. And you can actually do this with us. So if you're ready, if you're not, pause this now at home. Are we ready? Okay, so do the best you can. Just circle them. If you're done early, just chill out. Yeah, Evelyn?
Oh my gosh.
I'm thinking of the perfect thing.
Oh.
Start the timer now.
Go. Go. Yes, go.
Oh, wait here.
Noah has just walked in. We're very happy. 5 minutes left. minute. Stop! Okay, so let's take a quick look at this. So these I hope went well. After a couple problems, I think you maybe realize that you should just know what these look like. So I'm actually going to quickly show you as fast as I can without showing all of it, is that each of these look like this. And SI is the same thing as C. So, which has 2 lone pairs of electrons? Should have been letter A. Okay. Has a central atom with less than an octet of electrons. Borons and aluminums have less than an octet of electrons, especially. So that's letter C, because it's B. 6 is predicted to have the largest bond angle. Which one would that be? It would also have C. By the way, Noah's, some people have been representing you very well today. So, and 7 has a trigonal pyramidal molecular geometry. Which one? B. B, not A. B. Okay, I love those. Those usually are kind of, I know them or I don't, but usually we know them. I've hardly seen any problem where you're just guessing constantly. So hopefully we get a few of those. All right, let's take a look at some other things. 28. Stay with me here because we might get out a couple minutes late, but I don't want to be too late. A 2-liter sample of N2 and a 1-liter sample of AR, each originally at 1 atm, are combined in a 1-liter tank. The temperature is held constant. What is the total pressure? Guys, a 2-liter at 1 atm and a 1-liter at 1 atm, and they're both put in 1 liter. Well, if you shrink this, what happens to the pressure? It will double. The key to that was noticing that, because if you cut the volume in half, the pressure doubles. And if you want to actually see proof of that, that's Boyle's law, which I'm not asking you to come up with, but if you shrink it, the collisions double because it gets tighter. Okay? So that one, you know, a couple steps. Please be aware, I guess something like that, it probably isn't the simplest, probably not the most direct answer. Probably just take an extra breath, like, okay, wait, is there a trick to this? All right, number 30. This one did not need to be as hard as you made it, but you might have. It said that this thing equals 95. Now it's saying, what is this one? That's basically what it's saying. K prime, I'm just saying it's a different equation. So what happened in the equation first off? From here to here, it flipped, or, well, there's 2 things. It flipped, so we flip it, and then it what? Doubled. Now, none of them say 2, so they're actually bailing you out. So you wouldn't do that. If you double something, it squares. So what's the answer? E. Okay, no matter what, guys, a good miss would have been letter D. Reason why at least you would have seen that it flipped. Okay? So if you flip it, it gets, because now, look, guys, K, it's moving forward, so the products on the reactant are on top of the reactants. If it's going the other way, we flip those numbers, that means the K would flip. Number 33. So I'm going back and forth here. For an experiment, needs 100 mils of that. If the student starts, blah, 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 what would be the, how to prepare the solution with greatest accuracy? First off, you only have 2 options. It's either D or A. Reason why, volumetric pipette, volumetric flask. Here's why the answer I'm going to choose for this is you need 100 mils. If you use the pipette, what do you have to do? You have to pull it up 4 separate times. That's going to have error. You understand what I'm saying? You're like, yeah, but it's 25, so it'll be less. They both have 1 line. The difference is this is a volumetric, and the pipette looks like this. And you bring it up, and it's still to the line. Both horrible drawings. But you'd have to do 1 4 times. So the best answer is letter D, and that is the reason why. At least I'm interpreting that would be the answer. That's the one I would choose. So if it was 25, obviously it'd be the other thing. Number 38. The percent of silver in a solid sample is determined by converting silver and precipitating silver chloride. Failure to do which of the following could cause an error in analysis. Failure to do which of the following could cause an error in analysis. sorry, I'm not, now I get it. So any one of these things that you don't do would cause an error, okay? To be honest, what's the only thing that doesn't matter about getting a precipitation? It doesn't matter what temperature it's at. It's going to precipitate or it's not. So letter E is the only answer that matters. This is like the one we did in class. It's almost finding the one that doesn't matter. So if you have things like this, just look at these first. Like, oh yeah, that's important. Yep, that's important. Oh, that's important. Why wash to precipitate? You want to get everything off of it. Heat it. So to the constant mass, it's saying it has to be heated. Account for the mass of the weighing paper. You've got to subtract it correctly. But there's no such, it doesn't matter what the temperature is. So that one, if you didn't get it right, it's almost more about just getting confused with the options, frankly. Okay, number 40. Guys, which one's the strongest base? This reaction is spontaneous. It's whatever acts like a base. This gained an H. That's my base. If you got it wrong, you're just overthinking. Which one is the base? Don't get confused by saying which one's the stronger base. It's which one's acting like a base. That's the base. And the reason why, also, by the way, guys, it's spontaneous. So it's going in that direction. So the other direction, even if something's, yeah, but the other side, that's the conjugate base. Yeah, but it's not driving it back the other way because it's spontaneous. It's going this way. So I guess if ever it says spontaneous, always remember it's going forward. What's causing things to go forward? Okay, little math. I want to show you how I set this up. 45. All right, let's just agree that we're going to be about 5 minutes over so I don't feel like I have to rush because there are a few of these I want you to see. If you have to go, just go. But here is what this looks like. And it says that the pH is 4.0. Well, that means that's at equilibrium. If I take 10 to the negative anything, that's H plus or OH minus, depending on what it is. So, in essence, these things, what's 10 times 10 to the negative 4.0? That's 1 times 10 to the negative 4th. You got to know, pure pHs. 3s, 1 times 10 to the negative 3rd. 11, 1 times 10 to the negative 11 when you take 10 to that answer. If you don't know this math, good. I can help you right now. This is the initial amount minus what x is going to be, which is probably that. But do you know what these two together, multiply together is? These add, yeah. So it's 1 times 10 to the negative 8th. And if I'm basically dividing by an amount, what's my answer going to be? Yeah. It's going to be 1 times 10 to the negative 7. It's not going to be D anymore. I'm dividing it. Oh, did we get this one? What is number 47? What did you come up with?
C.
Yeah, it's C. What's an isomer? Same formula. I mean, same atoms, right? It could even look like the same formula, but different structure. In this case, they're trying to go out of their way to show you different structure. Anybody know what kind of functional group that is? Actually, technically, it's not. I shouldn't bring that up. Well, oh, yeah, I can. What is that? It's not a ketone. It's a... No, this one. Sorry.
Oh, no.
Sorry. It's an ether. Esther wears glasses.
There's 2.
I knew it was on it.
That's an alcohol, though. Alcohol is the one you got to know. All right, good. Which of the following substances has the greatest solubility with this? Okay, solubility. What is that? Polar or nonpolar? Nonpolar. So right away, nope, nope, nope. Why that one? Because that's looks like that. Okay. First off, if you have to go with one or the other, the greatest solubility, guys, if you have to dissolve something, it takes that much more. In liquids, it's easier just to dissolve. Secondly, what kind of IMF does a SiO2 have? Network solid. Really strong forces. That's not going down LD paths. So you could have figured out either way. Okay, this one I have a feeling some of you have this wrong. This one was hard. I thought it was hard. Okay, first, what's the one thing you can figure out of all these columns from that equation? There's only one immediately. S. Which one? Is it positive or negative? You go from 3 moles, right, to 2 moles. So right away, be smart. Get rid of that, right? Okay, now, unfortunately, you got to know some chemistry. Is this a reaction that can occur? Is this a real natural occurring reaction? Maybe you don't know, but I'm telling you no. This is hydrolysis. This is creating water from its most simplest forms. This is favored. Thank goodness. Okay, this is like where like water comes from. So what does that mean? This has to be spontaneous. And maybe you have to make a little bit of a leap. And unfortunately, I feel like they didn't quite give you enough information, but there it is. So automatically then, what else can I get rid of? I can get rid of E, right? Because G has to be positive. Okay, so please just try to think about this for a second. Is this favored to have a negative? Okay, remember, let me just, I want to make sure. If it's favored, what signs do I want? I want positive here. If it's perfectly favored, negative and a negative, right? So, what must it be? If it's this, both of these are saying that it's unfavored. I can't get it to be favored then. I mean, it's almost impossible. I don't have enough information. So that means that this must be a crazy amount. This is favored. Like, this is good. Like, yay. So it must be driving it enthalpy driven, not entropy driven. I view that as a hard problem. If you didn't get that one right, I wouldn't beat yourself up. What I'm trying to tell you is the S is saying it's not, but you're basically figured out it is. So why is it? One of these has to be favored. Okay, almost done. What is the empirical formula of the oxide? If you don't remember how to do this, let me show you. This is how easy this would have been. This was the plane crash activity back in first year chem. What we did, this is all you have to do though. You take a percentage. If you have 48% of 100 grams of something, you have 48 grams of that. So if you take 48 grams of oxygen and you multiply it by moles, you know how many atoms of oxygen you have. So simple math, what is that? 3. I'm actually done. Well, no, not technically. It's one or the other. Sorry. But there's a reason why they have these numbers. What do you think the mass of chromium is? Oh my God, it's 52. That's so weird. It's such a no, it's not a coincidence. Not at all.
Could they?
Okay, couple more.
Too smart.
This one I hope you got all right. It says the unknown acid is dissolved, 0.1 molar, none of that matters. Results are shown in the titration. Which one of the following could be the unknown acid? How do you figure it out? They gave you pKa's. Where's the pKa on here? The middle of the flat area, correct? I go straight across. Got to be B. And the thing is, they're not going to do like 3.8, 3.9, 4.0. Like, they're not going to do that. So, do you get pKa? Flat area of the buffer region. 2 left. This is a hard one. Permanganate, blah, blah, blah. Okay, so this is what you had to do. You basically had to get, guys, please. I need to know moles of this, and I'm given information about these two. So this is a mole ratio problem. This is one of those you just got to suck up and go, okay, I got to figure this out. So I have 0.2 moles. Oh, sorry, molarity. This is how it goes. Come on. Feeling rushed. If you do the math, this one's longer. How do I know? Gentlemen, please, I got like 3 more. How do I know which one's a limiting reactant? My gosh, I need 5 of these for every 2 of these. I need 5 of these for every 2 of these. I don't have that much more of that. So this is my limiting. See what I'm saying? I only have a little bit more. I need a lot more. So all you had to do at this point, and I know that for some of you, you may not have gotten this math. I mean, you got 2 times 2 is 4, and then figure out how many decimals it moves, right? 0.1, oh, that just moves it. But check it out. I have 10 per 5. So it just doubles. Oh. Now, if you didn't get that, I just want you to see how I did it. Yeah, well, how am I supposed to do that math? Slow down. Okay, 2 times 2, and then just move the decimal. Okay? That's how you do it, though. You got it right or not. There's a few that just, you got to take your time on. Final one. I hope we did this right. What's the answer? B. That is copper 2, right? Copper 2. thank you so much for coming. I hope you felt like it was worth your time. I really, really do appreciate it. If anybody else is still thinking or wanting to bring something and you're not sure for the breakfast, bagels have not been claimed. So I would love some bagels. I'm bringing my toaster. I don't love bagels, but people love bagels.
Oh, I love bagels. Cherry bagels. You know what?